Here we go. We have a question, search in sorted matrix. So you have given a strictly sorted 2D matrix of size n cross m and a integer x. We need to find whether the number x is present or not. So you have given this matrix and we need to find 14. So 14 is there, the answer is true. We got this matrix and we need to find 42. 42 is not there, so the answer is false. We go to this matrix, we need to find 101, it is there, the answer is true. So let's build the approach. So let's start with the brute force. So in the brute force, we will check with each and every element whether it is equal to the target element or not. So in this, the time complexity will be n cross m. But we can do better. The better approach will be to just implement the same algorithm that we did yesterday. So we got this element and this element. Is the target present between this range? No. So let's try to find a new I can say new row. So we go to this and this range. Is the target element present in this row? No, it is not there. So in this case, in the beta approach, the time complexity will be like we can say n cross log m, n cross log m. But we can do still better. So we got like these rows. How many rows are there? We got 1 2 3 4 5 6. So we got 6 rows. So 6 like we can say our L is here and R points to this value. Then we find our mid. 6 by 2 is 3. So 0 6 6 by 2, actually it is L is pointing to 0 and R is pointing to 5. So the mid will be L plus R by 2, which is 2. So we got this matrix. This row is the element present in this row. So we got this element and this element. Is the target element present between this and this range? No. So we know the target element is greater than the last element. Is the greater than the last element. So why not just check between this and this range? So we will increment our L to mid plus 1. So we go to this. Then we find our mid. L is 3. So the mid will be 4. So we go to 4. We try to find between this and this range. So we will try to implement binary search. We got this range. We know this is our target row, but we don't know whether the target itself is present in this row or not. So for that we need to apply binary search. So this is the better approach. What's the time complexity? So we got this. So it will be log n plus log m. We can apply this. But there's one more approach that I want to discuss here. So for this, let me erase the unnecessary thing. Then we know the elements are in a increasing order. First we go to this, then start with this, then start with this, this, and this. So the elements in a increasing order. So why not treat the matrix as a 1D array? So we are treating the matrix as 1D array. So for 1D array, let me give the indexes. So it will be 0, then 1, 2, 3, then its just greater element is present here. So I will give it index 4, 5, 6, 7. So let me give it the indexes. So I have given the indexes. So so let me do this. So here green represent the index if I treat the matrix as 1D array, and here red represents actually red is not important in this case. So anyways, red represent the I and j for this current cell. Red is not important. So let me erase the red. Actually let me write it. Then first of all we got our first element, then we got our last element. So what's the first element? First element is 0 and the last element present on this 23. How we got 23? How many rows are there? So 1, 2, 3, 4, 5, 6. So 6 multiply, how many columns are there? So only 4 columns. So uh, which is 24, but we start with zero base indexing, so we need to do -1. So we go to last element as 23. So R is 23. Then we find our mid. What is the mid? L plus R by 2. L plus R by 2. So 23 by 2, which is 12. So we got 12, but we don't know what's the 12th cell. So 12th cell is this, but how do we get this element? So in each row, only 4 elements are there. So 12, if I do divide by m, m means how many um, elements are there in one particular row. So in one particular row we only got m elements. M is in this case is 4. So 12 by 4, which is 3. So 3 is our ith index. So it represent what's the row. So if I divide it by m, we got our row. So then if I take the modulus with 3 with 4, because in each row we only got 4 elements, so we got 0. So it represent 3 and 0. So 3 and 0 cell we got